Problems need solutions.
Hello everyone, welcome to the first episode of Mathbuster. And as all of you know, in each episode of Mathbuster, we will bring a mathematical question with a very beautiful concept. And in this first episode of Mathbuster, we are bringing a question with limit concept with the concept of indeterminate limits. Let's see the question and start our first episode. So here is the question. Let p of x is equal to 1 plus twice x plus 7x squared plus 13x cubed, where x belongs to a set of real numbers. Given here is a polynomial, that is 1 plus twice x plus 7x squared plus 13x cubed, where x belongs to the set of real number. We have to calculate for all x belonging to the set of real number what is limit of n tending to infinity p of x by n to the power n. So let's start with this question. Okay. So first of all, we will see what is p of x by n. P of x by n is nothing but 1 plus 2 into x by n plus 7 into x squared by n squared plus 13 into x cubed divided by n cubed. Now, if n tends to infinity, 1 by n tends to 0. Therefore, p of x by n will tends to 1, because as 1 by n tends to 0, this will become 0, this term will become 0, this term will become 0, and 1 will be as same as 1. So p of x by n will tending towards 1 when n tends to infinity. So basically, this tends to 1 to the power infinity, right? When n tends to infinity, this limit tends to 1 to the power infinity. But here we have to take care that 1 to the power infinity is an indeterminate form of it. This is a special form. And under this form, 1 to the power infinity is not equal to 1 always. So what we do when we have limit of type 1 to the power infinity? We'll explain this with the help of this question. Okay. So let p of x by n whole to the power n is equal to y. This implies if we take natural logarithm on both sides, we will get ln of p of x by n whole to the power n is equal to ln of y. And as we know, since ln of a to the power b is equal to b of ln a, therefore the left hand side will become n into ln of p of x by n, which is equal to ln of y. Now let us take limit of n tends to infinity y is equal to limit of n tends to infinity e to the power log y. This is because since e to the power log n is equal to a. Now this is equal to e to the power limit of n tends to infinity ln of y. Now let us find what is limit of n tends to infinity ln y. Now limit of n tends to infinity ln of y is equal to limit of n tends to infinity n into ln of p of x by n. Now as n tends to infinity, p of x by n tends to, as we see in the first slide here, p p of x by n tends to 1. So this tends to 1. Then ln of p of x by n tends to ln of 1. That is 0. So when n tends to infinity, this term tends to 0 and this term tends to infinity. Now, infinity into 0 is an indeterminate form. Just convert it into 0 by 0 form, because when we get 0 by 0 form, we can apply L'Hopital rule over the limit, which says L'Hopital rule says limit of x tends to c f by g is equal to limit of x tends to c f dash c dash first derivative of f and first derivative of g whenever this is of the form 0 by 0. Now, if we convert this into ln of p of x by n divided by 1 by n, then this tends to 0 and 1 by n also tends to 0. So this is of the form 0 by 0. Now we will apply L'Hopital rule. After applying L'Hopital rule, we will get the denominator become minus 1 by n squared, and this becomes, see, ln of p of x by n is what? Ln of p of x by n is nothing but, it should become, see here, ln of p of x by n is ln of 1 plus twice x plus x by n plus 7 into x squared by n squared plus 13 into x cubed by n cubed. If we differentiate this with respect to n, what we will get? Dn of p of x by n, sorry, ln of p of x by n is equal to 1 plus twice x by n plus 7x squared by x squared plus 13 into x by n cubed. Like same rule, we will get 0 minus 2 into x by n squared minus 15 into x squared by n cubed minus 39 into x cubed by n equals 4. Therefore, this will become, if we take this as q, this will become q by minus 1 by n squared. Now, what is q by minus 1 by n squared? This is equal to 1 plus twice x by n plus 7x squared by n squared plus 30 into x cubed by n cubed divided by minus 1 by n squared. And here, twice x by n squared minus 14 into x squared by n cubed minus 39 into x cubed by n plus 4. And this will finally become 1 plus twice x by n plus 7x squared by n squared plus 15 into x cubed by n cubed. In the numerator, we will get twice x plus 14 into x squared by n plus 39 into x cubed by n squared. So now applying n tends to infinity over this, what we will get? This is nothing but limit of n tends to infinity 1 plus 2 into x by n plus 7 into x squared by n squared plus 13 into x cubed by n cubed. And in the numerator, what we get? We get twice x plus 14 into x squared by n plus 39 into x cube by n square, and as n tends to infinity, the terms having n in the denominator will become 0. So this becomes 0, this becomes 0, it becomes 0, this also becomes 0, this also becomes 0. At the end, we'll get twice x by 1, which is equal to twice x. So what we get? We get limit of n tends to infinity, ln of y is twice x. So limit of n tends to infinity, y will become e to the power twice x. And what was y? Y was nothing but, as we take here, p of x by n 4 to the power n. So this is nothing but limit of n tends to infinity, p of x by n to the power n is nothing but e to the power twice x. And you can see that here 1 to the power infinity gives e to the power twice x as the result, which is not equal to 1 whenever x is not equal to 0. And this is true for all x belongs to R, whether x is 0 or not. So this gives the answer as e to the power twice x. So you can see how we have to approach whenever we get a limit of the form 1 to the power infinity or 0 by 0 form. I think this is clear to all of you. And with this, we conclude the first episode of MathBuster. We promise that we'll be back with some more beautiful questions, beautiful concepts, with the approach and the motivation behind the question. Till then, bye bye. Take care. Thank you.